Hello, everyone, and welcome to our first lesson in the unit on integration, basic integration and integration by substitution. So this is just doing derivatives backwards. So if I gave you dy dx is equal to 6x, the question is, where did it come from? Can you work backwards to figure out what y must have been? So the answer would be 3x squared. And you can guess and check a little bit. You can say to yourself, well, it must have been an x squared, and then you did the 2 times something and got the 6, so it must have been a 3. So now see if you didn't get that one, see if you can do the next one. Again, a little bit of guess and check here. Hopefully you got that. And you can just test it really easily. People love integration because you can check all your answers by doing the derivative. 4x cubed plus 2. So are we sure? Are we sure that those are the regional functions? Think about these examples. If this is y, then y prime is equal to 6x. Well, that was the answer, but we didn't get 3x squared plus 4. Where did that 4 come from? And the derivative on number 2 is 4x cubed plus 2. But when we tried to do it backwards, we just got x to the 4th plus 2x. We didn't get that minus 1. Where did that minus 1 come from? But we never could have gotten that minus 1. In fact, if we had put a minus 14 here, it still would have had this derivative. This number is not going to affect the derivative at all. So the question is, how do we get the constants back? We can't. Hence the name indefinite integral. The correct graph will differ by some arbitrary constant that would create a vertical shift. So 3x squared was the original answer that we had, some kind of steep parabola. But 3x squared plus 4 is the exact same parabola, and everywhere the slopes are the same. So they have the same derivative, and the constant doesn't matter. Okay, so if you don't want to guess and check, there actually is a rule. The rule is that you just take the exponent and you add 1, and then you divide by the exponent. So for this one, oh, this is the symbol, by the way, integral. So it's like a little s. So the integral of 6x, you take the variable, it's to the first power, so I add 1, and then I divide by whatever number that is. So 6x squared divided by 2. And I get 3x. And I have to add c, because remember, I don't know what number was there, but there must have been, not there must have been, there could have been 0, but there could have been something there that would still create that derivative. And there's my first answer. Oh no, 3x squared, sorry. All right, next one. So I raise the exponent by 1. The 4 gets to stay, the 2 gets to stay. I raise the power by 1, and then I divide by whatever that power is. If there's no x there, it's really x to the 0, so now it's x to the first, technically divided by 1, but you don't have to write that. And then plus c. Of course, you should simplify it. X to the 4th plus 2x plus c. There we go. All right, I am going to write off to the side these answers here in case you think, I totally get this. I just want to do it on my own. You go for it. This one is going to be 5/3 x cubed minus x squared plus 3x plus c. This one is x cubed over 3 minus 3 over x plus 1 over x squared plus c. X cubed over 3 minus 4x plus c. Okay, but I am actually going to do them. So this first one, think of it as a -1. Remember that when there's no x there, it's x to the 0, so now it's x to the 1. And don't forget to add c. This is 5x. It was squared, so now it's cubed. This is 2x to the first, so now it's to the second. We add 1, and then you divide by whatever power you just made that. And then this was no x, so now there must be 1x to the first, so it's divided by 1, which of course you don't need to write that divided by 1 and the 2 over 2's cancel. So you should simplify your answer. And don't forget to add the c. There's probably at least one of you going, oh, I'm going to forget that c. Yeah, if you're taking a quiz and you forget the c once, I probably won't take off for it. If you forget it on a bunch of them, I'll have to take off. So try to remember it. Okay, there is no quotient rule in integration. There is no product rule in integration. You are going to have to simplify these before you do them. So simplify first. So this becomes, if I divide each of them individually by x cubed, I get x squared plus 3x to the negative 2 minus 2x to the negative 3. You probably remember doing this to do derivatives. Now we're going to do it for integration. This becomes x cubed over 3. Now be careful. I'm going to add 1, which gives me negative 1. And for the next one, I'm going to add 1, which gives me negative 2. So notice I kept this integral sign because I hadn't actually done the integral yet. This is very important to me because kids will make a mistake without it. The integral sign stays there until you actually do the integral. Be really careful here. You can put the minus out in front if you want to, and the x to the negative 1 can move to the bottom, but the 3 doesn't move. The 3 doesn't have a negative exponent. These 2's cancel and these negatives become positive, and you can move that square to the bottom. Don't forget your plus c. Again, there's no quotient rule, there's no product rule. You're always going to have to simplify first. I rewrite my integral symbol because I haven't actually done the integral. I'm still just fixing this up. Inners and the outers cancel and I get x squared minus 4. Now I can take away the integral symbol because I'm actually going to do the integral. Minus 4x. So I raised that power and divided. If it had no x, I'd give it an x. Are you feeling good about these? I hope so. Oh, I can just barely, oh, there it is, number 7. So on number 7, this is our first trig one. For trig, you are literally just going to do trig backwards. So if you think about what would make sine, it would come from cosine. But since the derivative of cosine is negative sine, I must be starting with negative cosine. There are rules for trig, which is pretty much just listing them backwards, but I literally just do them backwards. I think to myself, the derivative of cosine would be negative sine, so this must be negative cosine. And then what thing makes secant squared? Tangent. So either if you're in honors, make sure you have your list handy. If you are not in honors, you need to have those memorized. Number 8. Okay, so this isn't one that you have memorized, but just like with the other ones, you are going to have to simplify first. So I rewrite the integral symbol because I'm not actually doing the integral yet. I'm just simplifying. Cosine cubed over cosine squared would just be cosine. And then 1 over cosine squared. There's no quotient rule, so you are going to have to keep thinking about how can you simplify that. You can bring it to the top and call it secant squared. Now I'm not going to repeat the integral sign because I am actually going to do the integral. So the derivative of sine is cosine, and the derivative of what makes secant squared? Of tangent. So if you didn't have those rules memorized before, now you have to really have them memorized if you're in AP so you can go forward and backwards. This is a particularly tough one for people. It's tough with derivatives too. So the key is to rewrite it. I was going to write simplify, but rewrite it. So 7x to the 4/3 plus x. And now it's not so bad. So when I add 1, 4/3 plus 1 is 4/3 plus 3/3, which is 7/3, divided by 7/3, plus x squared over 2. Now you can't leave a complex fraction. So if you want to, you can think of, so I'm going to do it off to the side. You can think of the top one as over 1. That way, most people are more successful when they have two fractions, not just one. So we're going to keep the first one, change it from division to multiplication, and flip. Keep, change, flip. So the 7's cancel, and I get 3x to the 7/3 plus x squared over 2 plus c. And that is integration. There's a worksheet called Basic Integration, and you are now capable of doing all those problems. I will tell you that ones like 8 and 9 definitely give people the most trouble. So make sure that you simplify or rewrite it in a different way first. Okay, so how would you do the integral of 4x cubed times x to the 4th minus 1? Hopefully you said, well, I would just multiply it out first, because there's no product rule. So this is your only choice, is to simplify. However, what if this had been x to the 4th minus 1 to the 5th power? There's no way you're multiplying that out and then multiplying by 4x cubed. This problem would be way too hard. So there is a way to do it. Again, like I said, there's no quotient rule or product rule. There's just this: integration by substitution. Now notice I did not leave you any room on your paper to do this problem. That's because I want you to just put your pencils down and just watch what I'm about to do. So I'm going to substitute the hard part of this for u. So x to the 4th minus 1. And the reason that I'm going to do that is because if I could just change this to the integral u to the 5th, this would be fantastic. The integral of u to the 5th would be u to the 6th over 6. That would be lovely. Here's the catch. I haven't really pointed it out, but have you noticed the little dx off to the side? On every single problem has a little dx. That dx is telling you which variable you're going to do stuff to. So if I want to do this to u, if I want to raise u to the 6th, I need du. So how do I get that? Well, du with respect to x, so just like in derivatives, the bottom told you what variable you were doing stuff to. So du with respect to x is 4x cubed, which means by differentials that we just studied, du, if I multiply both sides by dx, du is 4x cubed dx. So do I have a 4x cubed dx? I do. 4x cubed dx. Those pieces make my du. So I am allowed to do this operation. That's where those other things went. People always say, where did the rest of it go? The 4x cubed dx is the du. And that's what allows me to do this problem. Now you can't leave the answer that way. The final answer would be u to the 6th. So x to the 4th minus 1 to the 6th over 6 plus c. All right, now we're going to do one together. We're going to do number 1 together so you can get the hang of it. So pretty much what you're always going to do is look for the complicated thing and make that u. Because if I could rewrite this as u to the 4th, this problem would be a piece of cake. So u is equal to 5x to the 3rd minus 2. The derivative of u with respect to x is 15x squared. The 2 goes away. And then I'm going to write it as du. I'm going to clear the fraction. 15x squared dx. So here's my integral. Here's my integral. This whole piece is going to become u to the 4th. And then this 15x squared dx, 15x squared dx, I'm going to write as du. All the pieces fit. It's a little puzzle. And if you're thinking, how do all the pieces always fit so nicely? They're not. This is the last time it's going to fit. The next one gets harder. So the integral is, you notice, keep the integral sign because I didn't actually take the integral yet. But now that I did, I remove the integral sign, u to the fifth over 5, which is equal to 5x to the third minus 2 to the fifth over 5 plus c. The great thing about integration is that every single quiz should be 100 going forward because you can take the derivative. If y is equal to 5x to the third minus 2 to the fifth over 5, then y prime, bring down the 5x to the third minus 2 to the fourth, times the derivative of the inside, 15x squared. The 5's cancel, and look what we get. 15x squared times 5x cubed minus 2 to the fourth. You can check every single one of them. I expect all hundreds going forward. Okay, let's do another one together. So the complicated thing is this 1 plus x squared. Be really careful that you don't let the complicated thing be the square root of 1 plus x squared. It's just the inside of the complicated thing. So my du dx is going to be 2x, which you're going to always want to rewrite as du is equal to 2x dx. So like I said, we're in our first one that has a problem. I am going to rewrite the integral. I don't need this 3. I'm going to do a funny thing. I'm just going to take it out, just like we did with derivatives. If you don't need it, just do the whole derivative without it. You can do the whole thing with integrals too. This is my u. Its power is to the 1/2. And I really need du. I have x dx. That's good. But I wish I had 2x dx. So I am literally, don't be mad, I am literally just going to add a 2 to my problem. How can I fix it so that that is a legitimate move? I can also add a 1/2. So for those of you that never liked completing the square, this is the same concept. You have to get this. Mathematically, I need the 2, but if I also put in a 1/2, I've balanced it out. So now the x and the dx and the 2, those 3 pieces are equivalent to du. But there's an extra 1/2 in the problem, but I can just leave it on the outside with the 3 times 1/2. So I'm just going to write this a little bit neater. So this is 3/2 integral of u to the 1/2 du. Let's make sure every piece is accounted for. 3, check. X dx 2, x dx 2, check. This funny radical is my u to the 1/2, check. Everything's accounted for. Now I can actually do the integral, and it's just u to the 1/2. So the 3/2 is just a constant. And I add 1, 3 over 2, because 1 over 2 plus 1 is 1 over 2 plus 2 over 2, which is going to be 3 over 2. You're going to want to get good at those without doing this work off to the side. Divided by 3/2 plus c. So I know you guys have your whole keep, change, flip thing. You might hear me say flip and multiply. This is being divided, so I'm going to flip it and multiply. Flip and multiply. In this particular case, the 3's are going to cancel, the 2's are going to cancel, and I'm left with just u to the 3/2. You actually don't have to add that c until the very end. Is equal to u to the 3/2. And what is u? So my final answer is 1 plus x squared to the 3/2 plus c. How can you check that super fast? If this is y, I take the derivative. I bring down the 3/2, 1 plus x squared, I subtract 1 to the 1/2 times the derivative of the inside, 2x, the 2's cancel, and I get 3x square roots of 1 plus x squared. Literally 15 seconds to check it. And it'll let you keep practicing your derivatives. All right, I'm sure there's a couple of you that have been thoroughly understand now. We are not doing anything else new today. We're just going to practice, and I'm going to go through every single one of them. But here are the next few answers. And number 5, which you can barely see. Okay, I'm actually going to do them. So my complicated thing is this 5 plus 2x cubed. The derivative of u with respect to x is 6x squared. I don't have a 6x squared. I do have, actually, I'm just going to rewrite this with the dx on the other side. I have the dx and I have the x squared, but I don't have the 6. So I'm just going to add a 6 and a 1/6 to balance it out. And now I'm going to account for every single piece. The 1/6 is not going to go away. The integral is not going to go away. The x squared, the dx, and the 6 is going to become my du. The 6, the x squared, and the dx. And then this last piece is my u to the 1/2. And look at that. That is such an easy integral to do. So this is going to be the 1/6 is still going to be there. I'm finally going to take away my integral sign because I'm actually going to do the integral. U to the 3/2 divided by 3/2, which we would like to flip and multiply. So instead of dividing by 3/2, I'm going to flip it to 2/3 and change it to multiplication. Now I can reduce a little bit. This 2 and this 6 reduce to 1/3. And multiplying straight across the top and straight across the bottom, I get 1/9 u to the 3/2. And my final answer is 1/9. You do have to replace the u back. 5 plus 2x cubed to the 3/2 plus c. This is my answer. I hope you're catching on. I hope you try the next one on your own. U is equal to 4x minus 1. Du is equal to 4 dx. I have the dx, but not the 4. So I add a 4 and a 1/4. I'm going to rewrite the 1/4. I'm going to rewrite the integral. I'm going to rewrite this as u to the 1/2. And I'm going to rewrite the 4 and the dx as du. Now that I have a du, I can actually do the integral. The 1/4 is a constant, so it stays out front. I get rid of the integral because I'm going to actually do the integral. I add 1 to the power, which becomes 3/2, and I divide by that same power. I don't like having a complex fraction, so I flip and multiply. You can flip it in the beginning. You don't have to put it on the other side like I did over there. This way it's next to the other fraction. The 4 and the 2 cancel to 1/2. Although if you did 2/12 and then reduce, that would also work. But it is going to reduce to 1/6 u to the 3/2. And my final answer is 1/6 4x minus 1, because I have to put the u back, to the 3/2 plus c. Okay, let's keep going. You're doing great. U is equal to 4 minus x squared, not dx, not yet. U is equal to 4 minus x squared. Du is equal to negative 2x. So I'll tell you right now, I usually just skip that step where I do du dx and then move the dx. You're probably already doing that as well. Okay, let's replace as many things as we can. I have the x to dx, but I don't have the negative 2. Make sure you use parentheses, otherwise it's subtract. And then I need a negative 1/2 on the outside to counter that negative 2. So negative 1/2, that stays. Integral stays. These three things, the negative 2, the x and the dx, all make du over square root of u, which is no good to us. So we need to switch that to u to the negative 1/2 du. You're pretty much never going to have a u. There's a few exceptions. where the u includes the square root. It's just the inside. And now we can actually do the integral. So I'm going to keep the negative 1/2, but I'm going to get rid of the integral symbol. I add 1 to negative 1/2, which is 1/2. I divide by 1/2. And if you can see it, these cancel. You're multiplying by 1/2 and dividing by 1/2, which just gives me negative u to the 1/2, which is negative. You can either write it, you can see I wrote it as square root, just because I don't know, I like square roots. Or you could have, but if you leave it as negative 4 minus x squared to the 1/2, that's just as correct. No answer is better than the other in this case. They're the same. All right, you're doing great. We have 3 more today. Number 6. Ooh, tough one. U is 3z squared plus 6z plus 5. My du is 6z plus 6. So even when I move the dz to the other side, this is a little tricky. You do need parentheses because otherwise just the 6 would be being multiplied by the dz. So make sure when you do that, you add the parentheses to make that work. Okay, this one's a little tricky. Normally people are working on their own, but since I am doing these for you, you can just multiply this by 6 and you'll get that 6z plus 6. But then you also have to put a 1/6 on the outside. So the 1/6 stays, the integral stays, the 6z plus 1, 6 times z plus 1 dz is my du, and this is u to the 1/3. Cube root and 1/3 are the same. But you can't do an integral with something on the bottom. There's no quotient rule. There's only one way to do integrals, and that's what the whole purpose of this u thing is that the only kind of integrals you can do are this kind. That's it. So we use u substitution to make it into the form that we can do, which is just one form. This gives me u to the, if I add 1, I get 2/3 divided by 2/3. I'm going to flip that. So here's my 1/6, and I'm going to multiply, flip and multiply. U to the 2/3. This cancels. 1, 2. So I get 1/4. And now I can put my u back in. That 4 is really terrible. I can put my u back in, which is 3z squared plus 6z plus 5 to the 2/3 plus c. Now I can add my c. All right, there are 2 left, and pretty much these are the same. You're just actually going to be able to use these to find c. So we have an extra step at the end. I will tell you the answer in case you are looking to do these on your own, which is great. I love it when you guys do them on your own and you are getting this without me. That's the goal. Y is equal to, so if you get these 2 right, then you can end this video early and have a great day. All right, if you either got them wrong or you just want to watch the whole thing, our u is going to be 1 plus x cubed. My du is going to be 3x squared dx. I've already moved the dx from du dx to up there. So on this, I'm going to multiply both sides by dx right away. And now I'm going to integrate both sides. So there was no integral symbol there, but the integral of dy is going to become y because I'm integrating with respect to y. So think about it as there's a 1 dy there, which when you integrate becomes y. This side is with respect to x, but it's too complicated. So I'm actually going to change it to be with respect to u. I have the 3x squared dx, the 3x squared, I have exactly what I need. So I can change it to, oh, but not yet, because I'm going to integrate both sides. So u to the 1/2 du. Now I'm going to integrate. You really should integrate both sides in the same step just to keep your work orderly. So on this side, integrating with respect to y is just y. And integrating this side with respect to u is u to the 3/2 divided by 3/2, which of course I'm going to flip and multiply. So 2/3 u to the 3/2, which last time 2/3 1 plus x cubed to the 3/2 plus c. So like I said, whatever this graph is, it's plus c. The derivative isn't going to change at any value. The slope is just going to keep staying the same, even if I move the graph up and down. But now it says that when y is equal to 1, x is 0. So this graph, whatever it is, has 0, 1 as a point. Now it can't be any of them. Now we can actually find the c that makes the graph true. This is not the graph, of course. But let's plug that in. So when x is 0, y is 1. 2/3 1 plus 0 to the 3/2 plus c. So 1 to the any power is just 1. So this is 2/3 plus c. Subtract 2/3 from both sides, and I get 1/3. So my final answer is y is equal to 2/3 1 plus x cubed to the 3/2 plus 1/3. That's my c. That's how you find c. All right, so last one, same thing. I'm going to move my dx to the other side. And now I have dy is equal to 4x times x squared minus 8 to the negative 1/3 dx. So I'm going to put in an integral symbol, just like you guys would square root both sides or square both sides. I'm going to integrate both sides. And when I integrate this side with respect to y, there's just a 1 there. So this is going to become y. But I'm not going to do it yet because it's nice to integrate everything at the same time. And I'm going to stop and do u substitution on this one. So u is x squared minus 8. Du is equal to 2x dx. I don't have a 2x dx. I have a 4x dx. So there's two ways to handle this. One is some people say, okay, well, I'll just break the 4 into 2 and 2, and then I have a 2x dx. This is fantastic. If you understand that, that's a fantastic way to do it, truly. But a lot of people don't quite get that. So I'm going to just show you what I consider to be the safer way to do it. The safer way to do it would be to take the 4 out, and then you would have x times x squared minus x squared. I don't know why that's not writing, sorry. Take the 4 out, write the x, and then x squared minus 8 to the negative 1/3 dx. And then do it the way you always do. Put a 2 in and put a 1/2 in. Most people get that. So the 4 is like a constant. You just leave it on the outside, and then you add your 2 and you add your 1/2 like you always do. That would give me a 2 on the outside. The x, the dx, and the 2 give me my du. And this is my u to the negative 1/3. It'll give you the next same step no matter which way you do it. All right, the derivative of the integral of dy is just y. And the integral of this side, the 2 is constant. I'm taking the integral, so I take the integral sign away. I'm adding 1, which gives me 2/3. I'm dividing by 2/3. And the du goes away because I've done the integral. That was just there to tell me what was the variable I was doing stuff to. So I am going to cross this out and change it to multiplication. And then my 2's cancel. So I get y is equal to 3u to the 2/3. And again, what's up with this pen? U to the 2/3. Which I'm going to switch back to 3 x squared minus 8 to the 2/3 plus c. So we've been stopping here for our answer. But now it says that when y is equal to 0, x is 0. So I put a 0 in for y and a 0 in for x. 3 times 0 squared minus 8 to the 2/3 plus c. So you do have to know a little bit of math here. 8, negative 8 to the 2/3 is the same thing as the cube root of negative 8 and then squared. So cube root of negative 8 is negative 2, squared is 4, plus c. So 0 is equal to 12 plus c. Subtract 12 from both sides, and you get c is equal to negative 12. So my final answer, taking this and putting in the c that we just found, is y is equal to 3 times x squared minus 8 to the 2/3 minus 12. You did it. You learned how to integrate. Great job. Have a good day.